Alright, welcome back. Today we're going to continue our discussion of solving triangles, and the law of sines is what we discussed yesterday, and it had some limitations with it. We always needed to know a side and its opposite angle to be able to use law of sines for it to even be beneficial, and that don't always happen for us. And in those cases when it doesn't happen, we have law of cosines that can pop in and sometimes help us solve. So today we're going to just discuss law of cosines, get a few quick examples. Alright, a neat thing about law of cosines, just like law of sines, this is going to work for all types of triangles. And so we don't have to be just a right triangle anymore still. It's still going to work for everything. So the triangles, we'll just use triangle ABC. We'll label the little sides little a, little b, and little c, just like before. The formula for this is a little longer, but it's going to look familiar. And how it starts out is a squared equals b squared plus c squared. So that's going to resemble our Pythagorean theorem. Then we have to add a little bit on. And what we add on is a minus 2bc cosine big A. And I'm going to give you a minute to write that down and talk about this. So it looks like Pythagorean there starting out. And then the minus 2bc cosine of A, that is the addition. And one way that I remember that is if on my right side of my equal sign, if I use b squared plus c squared, the bc goes with that too. So the a is used on one side of the equals and the other two are used multiple times. Now whatever little side we have on the left side, that's going to be the big angle over there on the end. So it always starts and ends with a big A, little a. And then the b's and c's would be used there in the middle. So that's an easy way sort of for me to just try to remember the formula. Now this does technically work with right triangles. If you'll type in cosine of 90, if it was a right angle that we were dealing with, trying to find the hypotenuse, cosine of 90, it will give you 0. And then 0 times 2 times b times c is going to be 0, and we're minusing 0, so all that would cancel off. And so this technically is Pythagorean theorem is sort of a derivation of this formula. Alright, if you can memorize that one formula, basically the others are just like that. They're going to switch and solve for like B instead of A. And what it does is just you switch every spot. So to see that written out, B squared is going to be equal to A squared plus C squared minus 2ac cosine of big B. So again, the little b and the big B are on the ends, and then the a's and the c's are both used twice on the equation. And then we're going to have one more formula, just the same thing, manipulating that same thing around to solve for c. So it's going to be little c squared equals a squared plus b squared minus 2ab cosine of big C. Really, that's one formula to learn, and just learn to put the different places in. Alright, let's try working this out in some problems. Finding measure of AB. Now, law of cosines, there's two main types of problems that is really used for. This one is like a side angle side where it's included angle between two sides. Law of cosines helps us get rolling with that. And then also with like a side, side, side. That's the two types of problems law of cosines really helps us out where law of sines was stuck. Alright, so we need to find on this one, let's label everything A, B, and C. And we're really wanting to solve for little c. And that's the equation I'll use first then. So it was c squared equals a squared plus b squared minus 2ab cosine of c. So that's my big formula. Like I said, that looks ugly and looks daunting, but it's going to clean up really nice. Plugging everything that we know in. We don't know c, so we're going to leave c squared equal, and then put in 13.5 for A, putting in 18.6 for our B, and squaring both of those, add them together, minus 2 times 13.5 times 18.6 times cosine of 31.5. This type of problem, I can take that whole right side and type it straight into a calculator, 13.5 squared, and just type in the whole thing exactly like it looks. When I hit enter there, I'll get c squared equals 100.0141. And that's c squared, so to finish that problem up, we know that to inverse the square, we would put our square root symbol there, take the square root of each side, and that would leave me C equals 10. And that would be what side AB is, so there's our solution. So, like I said, the formula looks really long, but lots of times it'll plug in pretty nice and clean up, and it's a lot of calculator work, really. All right, that's the first example. Moving on, here's another one. It's set up side angle side. We have triangle ABC. Little b over there is 10.7. Little a is 11.6. Big measure C is 114. It wants me to find the measure of angle A. Now, looking at this and starting out, I'm thinking, ooh, that would be nice for law of sines, but I don't have any side and its opposite. But I am giving the side angle side. That means I could find that little c, then I would have a side and its opposite. So I'm going to do law of cosines to start this problem out. Solve for that c side. So we're going to do c squared equals a squared plus b squared minus 2ab cosine of big C. Plug in all our numbers. It's going to give me c squared equals 11.6 squared plus 10.7 squared minus 2 times 11.6 times 10.7 times cosine of 114. I'm going to type the whole right side of my calculator again, and I'm going to get c squared equals 350.0183. To finish that up, take the square root of each side, and that will leave me with c equals 18.7. I'm going to go fill that in on my triangle. Now that I've got little c, I have big C and little c, so I do have a side and its opposite, so law of sines can be used again. Law of sines is typically quicker and not near as much algebra to deal with. We just have to do the cross multiplication. So I'm going to set up a law of sines now. Sine of 114 over the 18.7 is going to be equal to sine of A over 11.6. This is going to be just like yesterday's video now. Cross multiply and solve. So I'm going to have 11.6 sine of 114 equals 18.7 sine of A. I'm going to go ahead and say let's divide by that 18.7 on both sides. I'm going to type the left side of my calculator and get 0.5667. That's equal to sine A. And then we just need to undo the sine function, so we could do arc sine of both sides, and that would give me big A to be 34.5 degrees. And that's what our original question asked for, so there's our final solution. So that one, it asked, we had to sort of work out two problems to get around to the right information. Alright, next type, we're going to find the measure of angle B. This one, they've gave me the side information. And so here, I want to know, I'm going to label my little sides, little a, little b, little c. I'm wanting to find big B, so I want to use an equation that's got big B if I can. And so I'm going to go and pull out that b squared equals a squared plus c squared minus 2ac cosine of big B. Because I know little a, little b, little c, and that's every piece there except for the big B. So now just plug your numbers in. That would give me 14.3 squared equals 11 squared plus 11.5 squared minus 2 times 11 times 11.5 times cosine of big B. I'm going to go ahead and square up some of this and try to clean it up just a little first. I can't type all this in at once, so 14.3 squared gives me 204.49. Then I'm going to go ahead and do the 11 squared plus the 11.5 squared and do that as one piece, and that gives me 253.25. Then I'm going to have to go over and do the 2 times 11 times 11.5. That'll be minus 253 cosine of B. So really I've got to work these as two separate pieces because the cosine is getting multiplied with only that right side. Alright, now it's just down to an equation basically. It looks a little messy, but it'll clean up the same way. We have that 253.25 as positive on the right side. We want to move it over, so we're going to subtract 253.25 from both sides. That will give me a negative 48.76 on the left, and that's equal to the negative 253 cosine of b. So now to separate the negative 253 and the cosine b, I'm going to do the inverse and divide on both sides, keep my equation balanced. On the right side it will cancel. On the left I've got 0.1927 equals cosine of b. I need to undo the cosine function, so we're going to do arc cosine or cosine inverse. Do it to both sides. And on the right side it's just going to give me big B. On the left it's going to clean up to 78.9 degrees. Alright, and then we ask for big B. That's what we just found. Alright, last type of example, we're going to solve the triangle. Each one of these could be worked just a little different. Basically it's going to involve mostly law of cosines, might get us started. As soon as I can get in the law of sines, I'm going to try to go that route. Like I said, it seems like less work to me. I just prefer to use it. Alright, so looking at what we've got little a, little b, and little c. We've got side, side, side. So we can go find an angle just like we did in the last problem. It don't really matter which one you start with. I'll just start with a. So we'll use the formula a squared equals b squared plus c squared minus 2bc cosine of big A. Plug in all our numbers. So 14.7 squared equals 15.4 squared plus 7.54 squared minus 2 times 15.4 times 7.54 cosine of A. I'm going to clean this one up just like I did last problem. On the left side, I'm going to do the 14.7 squared first. And then I'm going to put the 15.4 squared, the plus the 7.54 squared in my calculator, hit enter. It gave me 294.0116. Then I brought down my minus sign. I went ahead and times 2 times 15.4 times 7.54. And I got 232.232. And then just bring down my cosine of A. Working it like last problem, I'm going to subtract that 294.0116 from both sides. That leaves me with a negative 77.9216. That equals the negative 232.232 cosine of A. Undo that by dividing again. That will give me positive 0.3355 equals cosine of A. Undo the cosine with my cosine inverse. And that gives me big A to be equal to 70.4. I'm going to go fill that in on my triangle. So now that I've got that information. Now I know big A and little a, so I know a side and its opposite. That opens up law of sines for me. So using that ratio, let's go solve for angle B. So I can set up the proportion sine 70.4 over 14.7 equals sine big B over 15.4. I'm going to cross multiply. 15.4 sine 70.4 equals 14.7 sine B. Go ahead and clean up and divide by that 14.7 to get sine B isolated. And type that whole chunk in my calculator on the left at once, and I'll get 0.9869 equals to sine B. Undo the sine function with arc sine. So that would give me B equals 80.7. I'm going to go fill that in on my triangle. Now I've got all three sides. I've got two of the angles. I could do law of sines again. I could go law of cosines. The quickest way, though, is I know how many degrees are in the triangle. So I'm just going to set it up and say, let's take the 180. Let's subtract the 70.4. Let's subtract the 80.7. And that gives me 28.9. And that's my final angle. So now I have all three angles. I was given all three sides, so I have solved the triangle. All right, that is law of cosines.